Now that we understand what a percent is, we can start to solve problems that involve percents. Percent problems, or any applications that involve percents, usually fall into one of three forms. We're either looking for a percent of a number, so calculating a percentage of a certain number, finding what percent one number is of another, or finding a number when a percent of that number is known. I've got a small typo here, that should be of that number is known. The way that a percent bar works is the bar, it's basically a rectangle, represents 100%. So if I had colored this whole thing in, that would represent 100%. If instead I only color in exactly half of it, then that colored in portion would represent 50%. And I can cut this however I want. I can make it into fifths, where I say each one of these sections is 20%. I can cut it into quarters, where I say each one of these sections is 25%. And it does not matter which one of the sections we're looking at. It's a lot like how we drew our fraction visuals. So the way that we're going to do this is maybe on the bottom of your percent bar, you have the percent version, and then on the top you would put the numerical value that you're associating that percent with. And I'm going to demonstrate how to use this for applications through various problems. So let's start with this problem. A house that sells for $275,000 requires a down payment. So anytime you buy a house, you have to put a little bit of money down. Depending on what loan you're approved for, you can pay anywhere from 3% of that house ticket price to 20%. And then, of course, the rest of the house is paid in monthly payments. Now, there's an example in the book that sounds similar to this, but I changed it for us Californians because you can't buy a house here for $92,000, and because house prices are so expensive, most of us aren't putting 20% down on a house. So I've changed it. This is our California version. Much more expensive house with maybe a smaller down payment to make it manageable. So the question here is, what's the minimum and maximum down payment? Like how much money do I need to save to be able to buy a house that costs $275,000? So to use a percent bar, remember the whole bar is 100%. And if we're talking about a house and the total house costs $275,000, then 100% is equivalent to that $275,000. And we could look at 50% of that. That would be half of the $275,000, which would be $137,500. But our question is actually talking about 3% to 20%. So although finding half is an easy reference point, that's not where we want to go. 3% is going to be like down here. So I want to know how much is 3% of that $275,000. So if I made my cuts this tiny, like this little yellow section that we had, what is that value? 3%. Well, remember that 3% is equivalent to 3 over 100. So we're looking at 3/100ths of the total house price. So to calculate this, we're going to take that percent, 3%. We're going to turn it into a fraction, 3 over 100. And we're trying to find 3% of the house price, which means we're looking at the first application, finding a percent of a number. In this case, we know the total, the base number, the largest number, and we know the percent, and we're trying to find a portion of the whole number. When I say whole, I don't mean whole like 0, 1, 2, 3, 4. I mean total number, so the total. We're trying to find a percent of that total. So 3%, first thing we do is write it into a fraction form, and then from there we multiply that fraction to the total of the house. And if you prefer decimals, there's no reason to leave your percent as a fraction. You could write this as 0.03 times the total house price. Remember that fractions and decimals are interchangeable, so it's really a personal preference there. So if I multiply 3 over 100, or if I multiply 0.03, I get the same number. It's 8,250. So that's the minimum that we would have to put down on this house. Of course, we can put more down so that our loan is smaller. So maybe instead of 3%, we want to look at the 20%. So 20% would be somewhere here. So if we looked at 20%, again, we're trying to find 20% of the total house price. So we're still looking at that same type of problem, finding percent of a number. So we'd take that percent, the 20%, and we'd convert it into a fraction, 20 over 100. Or we could convert it into a decimal. 20 over 100 would look like 0. Oops, that 0 looks terrible. 0.02. If we do use a fraction, we can reduce that. 20 over 100 actually reduces to 1/5. We're going to do the same thing we did with 3%. Take this fraction or decimal version of our percent and multiply it to the total house price. So multiplying our 1/5 times 275,000 gives us 55,000, and same with 2/100ths. Multiplying that to 275,000 would be $55,000. Now, $55,000 is quite a lot of money, but the reality is most of us don't put 20% down when we buy a house, so it's somewhere between $8,000 and $55,000 for your down payment. If your house is $275,000, there's houses that are way more expensive out there. Anyways, with this problem, what we did was we took an application and we drew a visual to help us see what information we know. For example, the total. So we know how much money it takes to fill up the entire percent bar. And then we looked at what we wanted to calculate. For example, 3% or 20%. We were looking for the values that would fill in these spaces. For example, this blue space is equivalent to $55,000. And if I were to make sure, I could check my work here. So if I got rid of this other stuff and I just said $55,000 is this 20%, which we also said is the same as 1/5, which means if we were to think about fractions, 5 of these blue rectangles should fill up the entire bar. So we could check that. If I have 55,000 in each one of these spaces, that would be 5 of them. So 55,000 times the 5 blocks that we have does give us the total 275,000. So maybe initially the percent bar doesn't seem like it's doing a whole lot, but it does allow you to wrap your brain around the information you have, the information you're looking for, and the information you found. If we had done something incorrectly here, when we went to check our work to show that 55,000 filling in each of those 5 spaces, if we had calculated that and it didn't come out to 275,000, we would know that we made a mistake. Let's try another problem. Here we're talking about Alberto. He has 45 correct answers on an 80-question test. And if you're good at calculating percents, maybe you already know what his percentage is, but if that's not something that's immediately quick for you, the percent bar can help us. Remember that the total number of questions is 80, which means 100% all the way at the end of the bar is the 80 questions. Now, one thing that we could do is try and cut this fraction bar until we find 45. So if we were able to divide this into different groups so that we can get exactly 45, that would be excellent. Another way to think about this is to say, I don't know where 45 goes. Does it go here? Does it go here? We don't know. And it's truly not that important. We just need to create a visual. So if I say 45 is the number of correct answers that Alberto got, what I can do is then put a corresponding percentage. And we don't know what that percent is, so I'm just going to put in as a variable here. And we're trying to find the percent that represents this blue shaded portion. So we know 45 correct answers fill in this blue shaded portion. We know 80 questions make up the entire bar. So what we're trying to do is figure out the percent that connects with this 45 question mark. So what we'll do is we'll say n percent is equal to n over 100. And we know that that proportion, n to 100, needs to be equal to the proportion 45 to 80. So I'm going to set that up 45 to 80. So 45 and n are in the same position. They coordinate to the same line on the percent bar, so they should both be in the numerator. 80 and 100 correspond to the same position, so they should both be in the same position in our proportion. They're both in the denominator. This type of problem is different than the last one we did. In this case, we are not finding the percent of a number. Instead, we're trying to find what percent one number is of another. We want to know what percent is 45 of 80. And we can tell that's the question that we're trying to answer because of the 4 numbers that are relevant to this question, only one of them is missing. We know the base, which is the total to make up the full bar. We know the part of that base that we're considering, that's the 45. The thing we don't know is the percent. I'd like to call this proportion a part over base equal to our percent, n over 100. This is a general form that you can use for any of these percent applications, no matter if it's like part 1, part 2, or the ones that we'll see in part 3. You can set up this part over base equals our percent value over 100. Once you identify the part and the base, you plug them in, and then you solve the proportion just like we did back in chapter 6. So our part is 45. Our base is 80. That's the same fraction that we created over here. And our percent is n over 100. We don't know what the percent is, so we're going to leave n as our variable. Notice that's the same fraction we got here. Setting these two equal, we can solve by cross-multiplying or simply by multiplying by the denominator, 100. Notice that if I multiply by 100 on both sides, the 100s cancel off. I'm left with n over here. So cross-multiplying would actually create an additional step for you. If your unknown is in the numerator, don't cross-multiply. If your unknown is in the denominator, that's when we cross-multiply. On the left-hand side, I have 100 times 45 over 80, but before I do that, I'm going to start reducing. I can cross off a pair of zeros on top and bottom. I also know that 10 and 8 are both even numbers, so I can reduce those by 2. That's about as far as we can go. So we're down to 5 times 45 over 4 is equal to n. All we need to do is multiply that left-hand side. That gives us 225 over 4. And if we wanted to approximate that or simplify into a mixed number, I'm running out of room over here. Let's write it on this side. A mixed number would be 56 and 1/4, or we can turn that into a decimal, 56.25, whatever makes the most sense. So this is the percent. Remember that n represents the parts out of 100. So when we go back to reread the question, what percent of his answers were correct? It would be the 56.25%. We don't need to convert that number. It's already a percent based on the way that we've set it up in this problem. You're probably going to guess we've already solved problems like 1, problems like 2. This one's probably a problem like 3. But before we assume that, let's make sure that we agree that's what's about to happen. In this problem, we have 42% of the parents of school children at Paxton School District are employed at Di Paloma University. If the number of parents employed by the university is 168, how many parents are there in the school district? Now let's start by filling in our percent bar. We know 42% of the parents are employed at the university. So let's just put a 42% line. We know we're working with 42%. Those are the people that are employed at the university. Then it goes on to say if the number of parents employed by the university is 168, we know that the 42% corresponds to that 168 parents. So those two numbers pair up well. The only number we don't know is how many parents are in the school district, the total number of parents in the school district. So in this case, we are looking at a question like part 3. We're finding a number, so this is the number we're looking for, when a percent of that number is known. So we know 42% of this number is 168. And we can again use that part over base equals n over 100 proportion to solve this. The part is 168. The base is the number that we don't know. N is the percent that we do have, which is 42. And we put 100 to represent that we're talking about that percent. Now in this case, to solve, we are going to cross multiply because our unknown is in the denominator. So that would look like 100 times 168 equals 42 times that unknown base b. I want b by itself, so I need to divide both sides by 42. That way b is alone on the right-hand side. Now before I multiply the terms on my left side, I notice that I've got some numbers here that can be reduced. For example, 42 and 100 are even, so I can cut those in half. 42 cut in half would be 21. If 21 can divide into 168, then we should try and divide that as well. So let's check. Yeah, in fact, 21 times 8 is 168. So I can do 8, which leaves us with 50 times 8 on the left is equal to that base b. 50 times 8 is going to be 400. Now, let's check that we agree with that. If 42% is 168, then the rest would need to be 100 minus 42%. So from 42% up to the rest, that would be 100 minus 42%. It's 58%. If the whole thing really is 400, 42% is 168, 58% of 100, that would look like 0.58 times, did I say of 100? I meant of 400. That would be 0.58 times 400, which is 232. So this whole section over here would be 232. If we add those together, 168 plus 232, we do get 400, which means we did this problem correctly. So again, we're using these percent bars to help understand how to set up these problems and to understand and identify which type of problem we're looking at. In any case, you can always use this proportion to solve these problems. The tricky part is recognizing what is a part, what is a base, and what are you looking for. Let's do one more problem here. This problem says Kelly bought a bicycle and a year later sold it for 20% less than what she paid for it. She sold the bike for $144. what did she pay for it? Now, one thing that we have to recognize is that we're looking for the original price of the bike. We're not looking for how much this other person bought the bike for. We want to know, how much did Kelly pay when she bought the bike? And the only clues that we have is that if she took a 20% loss, then it comes out to $144. So if we let the total percent bar be the price Kelly paid, and we say that she is reducing that by 20%, and that comes out to be, oh, I should put the minus 20% on bottom, shouldn't I? Minus 20%. So I'm representing the minus by drawing an arrow that points backwards from the 100% part. And that comes out to the price of $144. Now, we're not looking for this. We're not looking for 20% of what Kelly paid. We want to know what the base was. And to set up this proportion, the best way to do it is to find the percent on the left-hand side. Now we know that the blue, the right-hand side, is 20%, which means that the left-hand side has to be the remaining percentage. That would be 80%, because 80 plus 20 equals 100. So we've got 80% in yellow, 20% in blue, which means the percent that this person is paying is 80% of what Kelly paid. She is taking a 20% loss. This new person is buying it at 80% what Kelly paid. So we can write our proportion. Our part is the 144 over the 80%. And the base, oops, I wrote 80% where the base goes. Let's fix that. 8 here and the percent, and the base goes down here. And then we can solve it this way. If we had set it up the other way, 144 over our base equals 20 over 100, this answers a different question. This tells you how much the blue space is. But 144 is not the amount of money that goes here. 144 is the amount of money that fills in the yellow space. So it's really important to use our percent bar to realize that the 20% is telling us what we don't want to use, but it's helping us find the number we do want to use, the 80%. So we're not going to use the 20%. Instead, we're going to use the 80%. We'll cross multiply so that we have 100 times 144 equals 80. B, isolate B. And at this point, if you're comfortable with reducing fractions and you don't want to practice anymore, that's fine. Go ahead and just type in 100 times 144 over 80 into your calculator, and you'll see that the answer is 100. So this is the amount of money that Kelly paid when she bought the bicycle. And we can double check our work. We can check that 180 makes sense here. So if 144 is 80%, then 20% needs to be the remaining cost. So if we do 0.2 times 180, does that finish off the bar? So that would be 36. If 144 covers all of the yellow, and we add that to the 36, we do in fact get 180, which completes our percent bar, so we can feel confident that we did that correctly.